So far we have discussed formal definitions of big O, big omega, and theta. Okay, formal definitions of big O and theta. Now we will see the other two notations also. Next one is little o or small o. Okay, little o. When do we say that f of n is little o of g of n? When do we say that f of n is little o of g of n? Can we say that n cubed is little o of n power 4? That means, what does it mean? Order of growth of f of n is less than or equal to, strictly less than order of growth of g of n. That is the meaning, no? Order of growth of f of n is strictly less than order of growth of g of n. Okay. So now n cubed is little o of n power 4. Is that true or not? Is that true or not? N cubed is
Yes, sir.
little o of n power 4. That is
Yes, sir.
true. That is true. Now, can you give a definition for little o then, based on this? Based on this, or one more example: 7n cube plus 8n square plus 9n. Is it little o of n power 5? Is that true?
Yes, sir.
Okay, that is also true. That is also true. So there is simple definition for showing that f of n is little o of g. Now, if I take limit, we are going for large values of input. Now, limit n tends to infinite. 7n cube n cube by n power 4. Okay, now simply take n cube by n power 4. What is this value? Limit n tends to infinite, n cube by n power 4. What is its value? This can be written as limit n tends to infinite, n power 4. We can write it as we can write it as in n cubed into n. Is that correct? So if n cubed and cubed gets cancelled, then what is this we get? What is that we get? Limit n tends to infinite 1 by n. Limit n tends to infinite 1 by n. What is limit n tends to infinite 1 by n? What is limit n tends to infinity 1 by n?
Zero, sir.
It is 0. It is 0. So similarly, this example, this is with respect to say example 1. This is, now we call it as example 2. Now example 2 also, let us take limit n tends to infinity 7n cube plus 8n square plus 9n by n power 5. This can be written as, both sides we can take n cube common numerator. If I take n cube common in numerator, what is that we get? 7 plus 7 plus 7 plus 8 by n. Is that correct? 8 by n. Is that correct? Nine by n square. Is that correct? Numerator part. N cube, if we take common, is this correct? This is 8n cube by n 8n square. This is 9n cube by n square 9n. Is that correct? Okay, similarly, n power 5, I'll write it as n cubed into n square. Now n cubed gets cancelled. N cubed gets cancelled. Okay. Now what is the remaining part? Limit n tends to infinite. 7 plus 8 by n plus 9 by n square by n square. Is that okay? What is this value? What is this value? What is this value? What is
Zero,
limit n
sir.
tends to infinite 7? What is limit n tends to infinite 7? There is no n part, so no problem. What is limit n tends to infinite 8 by n? This can be written as 8 is independent. Limit 8 times limit n tends to infinite 1 by n. Is that correct? Is that correct? What is limit n tends to infinite 1 by n? What is limit n tends to infinite? 0. So it is 8 into 0. So it is 0. Is that correct? So similarly, what is limit n tends to infinite 9 by n square?
0.
This also same way we can show that it is also 0. So now what is the value that we get here? What is the value we get here?
0.
7 plus 0 plus 0 by limit n tends to infinite 1 by n square into this way we can write. Is it okay? Is that okay? What is this value again? 1 by n square is there, no? 1 by n square, what is this value? What is this value? Limit n tends to infinite 1 by n square into something. What is limit n tends to infinite 1 by n square?
0.
0. So finally, what is the value that we have got? 0. That is 0. That means, what does it mean here? If limit n tends to infinite, if limit n tends to infinite, f of n by g of n, if I take, what is the value it is happening in this case? Provide, if you know that order of growth of f of n is lower than order of, strictly lower than order of growth of g of n, then what is this value? Limit n tends to infinite f of n by g of n?
0.
0. So this is another definition, one definition for little o. When we say that f of n is little o of g of n, we say that f of n is little o of g of n.
When limit n
tends to infinite, f of n by g of n equal to 0, 0, then we say that order of growth of f of n is strictly lower than order of growth of g of n. Is that okay? Is that okay? We'll see some more examples for definition also. I'll show you. If please, the function f of n is little o of g of n if and only if limit n tends to infinite f of n by g of n is 0. This is simple, similar to that. This is same similar example. Here we were able to show that this is also 0. F of n by g of n. This is f of n. This is g of n. F of n by g of n is 0. Same procedure. Hence, by the formal definitions, we conclude that 7n square plus 8n plus 9 is little o of n cube. Similarly, if we take limit n tends to infinite, last class I explained this, if we take limit n tends to infinite, any polynomial function by exponential function, but base we should take it as greater than 1. What is the value that we get? We know that this function order of growth is strictly higher than order of growth of polynomial, no? Order of growth of polynomial. So that is what is that? It is a polynomial function. It is a polynomial function. It is n squared, n cubed, n power 2.3, n power 5.6, something like that. It's a polynomial function. Here it is. That's why a greater than 1. base is greater than 1. It is exponential function. This limit, if we take, it is 0, because if this value, no, it is very much high when compared with this. So limit becomes 0. Hence, what is that we are able to say? This we have already.
Apply this limit theorem on Vigo notation.
So there, if we want one condition that we can say is, for example, limit n tends to infinite, f of n by g of n, is constant or
0.
Whether
Yeah.
it works?
Yeah, it works. Yeah.
Okay, similarly, for this we have similar to the inequality. Here also we can give inequality. That is also there. Both sides. It is either constant or it becomes 0. Now, is this true? N power 4 is little o of 2 power 0.5 into n. N power 4 is 2 power 0.5 into n. Is that true? Okay, first let us see n power 4, 2 power 0.5 into n. 2 power 0.5, I can write it as 2 power 1 by 2 whole power n. Is that correct? 1.5 means 1 by 2 only, no? What is 2 power 1 by 2? It is square root of 2. It is square root of 2 whole power n. What is square root of 2? 1.414, no? Whole power n. Now you tell me which is more. One side n power 4, other side 1.4 whole power n. Which is more? Which has a higher order of growth?
1.4 over the common.
That's not higher order of growth. Hence, is this true or false?
True.
That is true. What about second one? Is this true or false?
True.
What is its order of growth? It is n square finally. This is 1.5 power n. It is of the form n power b. This is of the form a power n, where a is greater than 1. No? Is that okay? That's why it is strictly lower. Is it clear? Is it clear? Now, one more example also we discuss. One more example, what is that we discuss? One side polylogarithmic function, log n whole power, say some a. Another side polynomial function, n power b. Out of this, which has lower order of growth? This is polynomial in the logarithm function, polylogarithmic.
This is
Side is the lower.
log n whole power a.
Lower. That means if we take limit n tends to infinite log n power a by n power b, this is 0. That is 0. That's why it is lower. Okay, similarly, we have another notation called, what is the last notation?
Big, small theta, small omega.
Small omega, little omega. Please, this definition, everything you only have to tell. Okay, one example I give, when we say that f of n is little omega of g of n, that means what? Order of growth of f of n is strictly higher than, this implies this order of growth of g of n. Correct? For example, n cube is little omega of n. Is that correct? N cubed is little omega of n. Is that true or not?
Yes, true.
Yes, true.
It is true. Similarly, example 2, 7n cube plus 8n square plus 9n is little omega of n power 4. Yeah, sorry, n square. Is that true?
Yes.
Yes.
True.
It is n squared, not 4. N squared. This is also true. This is also true. Now, similar to previous one, here also if I take limit, okay, no? Limit n tends to infinite, say f of n by g of n, f of n by g of n. What is this value? Limit n tends to infinite, n cubed by n. In case of example 1, n cubed by n. What is this value?
Infinite.
It is infinite. Instead of this, if I take definition like this, limit n tends to infinite, g of n by f of n.
Then 0.
Limit n tends to infinite. Okay, thanks. N by n cube. What is this value? What is this value?
0.
It is 0. No, it is n square will get. It is same as limit n tends to infinite 1 by n square. It is 0. It is 0. Is that okay? Similarly, this one, 7n cube, limit n tends to infinite, f of n by g of n. That is, limit n tends to infinite, 7n cube plus 8n square plus 9n divided by n square. What is this value? What is this value?
Infinite.
Infinite.
Finite. What about this? The other side, if I take n squared by 7n cube plus 8n square plus 9n,
It is 0.
it is 0. Okay. Now, what is limit n tends to infinite? Log n whole power b by a power n, a power n. A power n,
B log n divided.
where a is greater than 1. Okay, we know that
It is 0. Yeah.
It is 0.
it is 0. Okay, so that means what? That means order of growth of, which implies order of growth of log n whole power b is strictly lower than order of growth of a power n. What is this? This is Pauli logarithmic function. This is
Exponential.
exponential function. Okay. Why is it true? We know that polylogarithmic function order of growth is, we have already seen, no, less than polynomial function whose order of growth is less than exponential function. Okay, hence polylogarithmic is automatically strictly lower than exponential, no? Strictly lower than exponential. Is that okay? Is that okay?
Yes. Yes.
Okay. So now can you give me definition for this? What is definition for this? Okay, you please read this. Is it clear, the definition? Is the definition clear? Same thing, no? Whatever we discussed.
Yes. Yes.
Yes, sir.
Okay. Or up to this. So from equation 1, this we have already seen. Equation 1, if we replace n with log n in equation 1, n power b is there, no? This n I replace with log n. That means log n power b. Here a power n, a I replace with 2 power a. A power n log n whole power b. Here a two. Correct, no? Okay. So what is that? We are doing a in place of a. Two power a. Again here n is there, no? This I forgot. I'm thinking only n, why it is log n, log n. Then what is that we get? It is same as
2 power a log n.
it is okay. Only confusion is here, no? 2 power a log n. This we can interchange, no?
Log n 2 power a.
N power log 2 power a. Log 2 power a. Base is e we take base as e. Okay. Now what? Let us take 2 as base. Okay, let us take 2 as base. Then what happens? Then what happens? Base is 2, I have assumed. Okay. Then what is this?
N power a.
N power a. So asymptotically, whether log n base 7, log n base 2, is there any difference between order of growth?
Log n base 7.
Okay, what can you say about order of growth of this and order of growth of log 7 base, log n base 2? Which is more?
Order of growth will remain same.
Order of growth, is it same?
Because if you want to convert like with the same base, we can write log n base 7, log n base 2 divided by log 7. Similarly, so it's a log 7 base 2. It's a constant, so order of growth will remain log n at both the sides.
All of you agree with the sir's answer? No, what sir is saying, no?
Base value is different here.
This log n base 2, we can write it as log n base 7 into log 7 base 2. Is this correct? We know that log a base b is same as log a base c times log c base b, no? We have this property, no? Based on that, log n base 2, is it possible to write it as log n base 7 into log 7 base 2?
Yes, sir. It is a constant. We can.
Now what happens? This side order of growth is log n base 7. This side, what is the order of growth? What is highest order term? Only one term. This is only highest order, but the constants we need to ignore. No. What are constant coefficients here? This is constant coefficients. If we ignore, what is that we got? What is that we get here? Order of growth log n base 7. That means both have same order of growth. Is that correct? That's why in no textbook they mention, whenever they write order of growth, it is not required to mention base. Whenever we talk about order of growth, is it necessary to mention the base?
No,
Is it necessary to mention base?
No, sir.
no, sir.
In any textbook, no, simply they write like this: log n, a big O of log n, or theta of log n. Have you seen any textbook where they mention log n base 2?
Log n is sufficient. Base 2 is not important.
Base 2, even if you mention that, it does not mean that is wrong, but it is not required.
In several literature, I found 3 different terminology for logarithmic. One is LG, other is ln, and third one is log.
Log 1 is base 10, 1 is base E, 1 is base 2. Oh, the other one you are saying, sir. That's base 10, base E, base 2. That's all.
Okay, yeah.
That in the textbook, no, okay, no, they clearly mention. Okay, no, log n means it is base E, log means whatever notation they are using, no, they clearly mention somewhere. Okay, that's not a problem. Whether we write ln of n or log of n, it doesn't matter. Okay.
Just my counter argument is if there is base doesn't matter, why the authors are writing in a different notation, LG, LN, where
No, it is not.
generally the people confused.
The exact order of growth point of view, there is no difference at all. There is no difference. Have you seen any textbook writing 2 into n square order of growth is big O of 2n square? Or order of it finally running time or whatever it may be, it is 3 into n square. Like this, have you seen any textbook?
No, not in any book. Yeah.
They don't, not necessary. If they write like this, does it mean that it is wrong?
No, as per definition, formal definition.
It's not required. No, it is automatically taken care here. It is automatically taken care here. That's why they don't actually write this. They don't actually write this. Okay. Here
Yeah,
also,
fine.
that as we discussed earlier, log n base e, log n base 10. Both are same, no?
Yeah, both same.
Both same. Well, there is no point in explicitly mentioning, no?
Yeah, correct.
Is there any confusion?
Confusion now.
Okay, okay. So now from this, what is clear? Is this clear? What is order of growth of polylogarithmic function is strictly lower than order of growth of polynomial function. That's why what is here? What is that we write here? N power a is, it is missing. N power a is omega of log n whole power b. Is that correct? Is that correct? Okay. So now, so far we have discussed this asymptotic notations. Okay, 5 asymptotic notations, informal definitions and formal definitions. All of you should understand this clearly. Okay, no, clearly. If we don't understand, no, sometimes we don't understand the question itself. In the question itself, they use no big O of n or big O of n log n time algorithm or theta of n or big omega of n. Okay. Forget about answering that question. Okay, now first of all, we don't understand question. These are like alphabets of this course. Okay. Is everything, all 5 notations, is it clear to everyone? Is it clear to everyone?
Yes, sir.
Yes, sir.
Okay. If you have any difficulty, okay, you can even ask me or later if you have any difficulty. No, I can take, other than this 4:30 to 7:30, I can take one additional class. Okay, at that time again I'll explain, because without understanding this other things you find it a bit difficult whenever we talk about running time, all those things. Okay, you please watch this go through the PPT and try to understand. Okay, okay. Next thing is, now we are familiar with this asymptotic notations. We are familiar with asymptotic notation. Next question is, we go for now analysis. Analysis. Whatever analysis we do, what does analysis mean? What does analysis mean? Analysis means analysis of algorithms. What does analysis of algorithm mean? What does analysis?
You want to find the computation as well as the
Predicting the resources of
the problem,
algorithms
how to solve the
required.
problem.
No.
That is a priori analysis and posterior analysis, 2 types of analysis.
How much time is required to execute the given problem or a particular task?
That is predicting the resources that the algorithm requires.
Yes.
Algorithm requires. Most of the time we talk about time only, CPU time. So what are the 2 resources that we consider? CPU time
and memory.
Memory. But out of these 2, which is more precious resource?
CPU.
Time. So we confine most of the time, textbooks also know, they confine most of the time to time only. Okay, now what is the amount of CPU time? So then given an algorithm, how to find what is the amount of time that algorithm takes? That's what we need to do. We need to understand. Say this is some algorithm. This is name. Name of the algorithm. These are some parameters, whatever it may be. This is say step 1, step 2, step 3, and so on. Say this is last step. Last step. So now, what is the model that we use for analysis? Model for analysis?
RAM model.
RAM model. Thank you. RAM model of computation. RAM model. RAM model of computation. That means here all main important, all operations. Is there any difference between operations? Amount of time they take? All operations take?
No, sir.
Order of one
Same time.
Constant time. Constant time.
Yes, sir.
Now, in addition to that, we are only interested in what? We are only interested in what?
Order of growth.
Order of growth of that algorithm. That's all, no?
Yes, sir.
Order of growth of that algorithm. So each step, some operation is performed. What is the operation? Okay, now let us say this is a one step. So for each step we write operation that is to be that is performed. Operation that may be some addition or something like this. Next, operation count. Operation count. So some operation is performed. If I assume that n is input size, number of times this operation is performed in step 1. That if I call it as f1 of n, I say t1 of n. Similarly, here some operation, what is that performed? Say some comparison. Say it is t2 of n, and so on. In general, here some operation is performed, and this is t last of n. Then what is that we are taking? Total how many operations are performed means tn is sigma. We are taking sum of all this thing, no? Same thing we have already discussed. Okay. What is this t of n called? What is this t of n called?
Running time. Total operation.
Operation count. Loosely speaking, running time of that algorithm. Running time of the algorithm where n is input size. Really, are we interested in the entire t of n value? Say, if, for example, t of n is again say 7n square plus 8n plus 9. Are we interested in this entire value?
No, maximum
No.
term is enough.
That means we ignore this finally approximately n square. We just want this. Then we get it out. Okay, if we are interested in the highest order term, okay, no, highest order term, then why should we calculate for terms where the number of operations performed is very less? Why should I do calculation for each step? Is it worth doing?
No, sir.
Then what is that we can, if there are 1 lakh steps in our algorithm, do I need to do for each step in the algorithm? What is the operation that is performed? How many times it is performed? Second step, what is the operation that is performed? How many times it is performed? Last 1 lakh step, what is the operation that is performed? How many times it is performed? Then take summation over all this. Is it necessary? No. Why? We are only interested in asymptotic analysis. No, we are only doing asymptotic analysis. That is, as n tends to infinite, what is the value? As n tends to infinite. That means what? In that case, what matters? Only order of growth matters. No, order of growth matters. So if this is the case, then what is that we need to do? So that means all steps in the algorithm, is it necessary to count how many operations are performed? Is it necessary to count for all steps in the algorithm how many operations are performed? Is it necessary?
Maximum.
No, sir.
No. For example, one step, one operation is performed only say 3 times or 1 time. Is it necessary to count that?
No, no.
One time is
One
sufficient.
step, total T of n is this. One step, one operation is performed say n times. Is it necessary to count that? Is it necessary to count and include it?
If it is n times, we need to consider it.
But
So
I
most
know that
frequent performed operations we
no,
considered.
I know that final answer is if you know that it is 7n square plus 8n plus 9, an operation in this step, one operation is performed, and whatever operation is performed, it is performed n times only. But
Yeah.
total number of operations performed in this algorithm, T of n value is 7n square plus 8n plus 9. Now you tell me, is it worth considering this?
If we go through all the steps, then we will come to know the complete equation, and then we can
My
find
question
higher.
is, after going through all the steps, we have understood that T of n is 7n square plus 8n plus 9. Now my question, I am coming back. Okay, we know that third step is performed only, whatever operation is performed here, it is performed only n times. Now, if you know that T of n is 7n square plus 8n plus 9, is it worth counting third step? What is the
No.
operation performed?
No,
How many
not
times it is
not
performed?
required.
It's not required, no? That
Yes.
means in general, which steps we need to actually concentrate more?
Important.
What does important mean? So important steps. Okay, that is
In the iteration. Those were the
important steps.
Loop.
Important steps. And
iterations.
that means how do we know whether this step is important or not important?
Basing on number of loops that we are using.
Also, why are we saying that number of loops? What is the intention behind saying that?
Yeah, the
Yes.
for
Our
loop means
intention is
take
in which step number of operations performed is more. We concentrate only on those steps, no? Whichever steps in the algorithm, the number of times that operation is performed is more. Okay, no, we concentrate only on those steps and we count how many times that operation is performed with the intention that automatically tells me what is the order of growth of entire algorithm. Is that okay? So finally, we are interested in order of growth. Once we are interested in order of growth, the steps where number of operations performed is less, they become insignificant, not significant, not significant. Then we need to concentrate on only those steps where number of operations performed is more, or which contribute most to the total running time of that algorithm, or total operation count. Is that okay? Is that okay? And what are those steps? As you said earlier, those are the steps which are actually, where inside loops, where they are repeated more number of times. They are repeated more number of times. Okay, that we'll see with an example. We'll see with an example. So finally, are we going to count for each and every step in the algorithm? What is the operation that is performed and how many times it is performed? Is it necessary? Is it necessary?
No.
No, it's not required. It's not required. Okay. Somehow, if we are able to find what is the order of growth of the entire running time of that algorithm, then that is sufficient. For that, we need to decide which steps are most important. By looking at algorithm, if you see some automatically will come to know. Automatically will come to know. They are actually inside loops or where most of the work is done. Okay. Okay. Now, this is called analysis of algorithm. No, this is called analysis. So find T of n. So in order to analyze this, what is the first thing we need to do? If some algorithm is given, what is the first thing that we need to do? We need to know what is the parameter that indicates input size. This should be important. Why? Because finally we write total number of operations performed in terms of input size only, no? It is function of input size only, no? So first
Yes,
we
sir.
should know which parameter is, what is the parameter that indicates input size? Parameter which indicates input size. Next, among all steps, which each step different operation are same, sometimes repeated operation is performed. Among all operations in the algorithm, which is most important operation? Okay, now which is most important operation. In one algorithm, there may be different operations. Then we should be able to decide what is the most important operation in that algorithm. Okay, what is next thing that we need to do? First, parameter indicating input size. Parameter indicating input size. What is second thing? What is the second thing? What is the second thing? What is the second thing?
Frequent operations performed.
The most important operation. That hereafter I call it as basic operation. Basic operation or most important operation. Third step. Let T of n be the running time of this algorithm. Then we need to write what is the value of T of n in this entire algorithm. Okay. So, but there is one important step there that I'll come to it later. After getting T of n, you simplify it and find its order of growth of T of n. After getting order of growth, in last step, you represent it using some asymptotic notation. Represent T of n using some asymptotic notation. Okay, some asymptotic notation. Okay, some asymptotic notation. Okay, I show the same steps, whatever I explained, then we go to example. See, first, algorithms, whatever we consider, no, we classify broadly into, I request all the participants to turn your microphone, to keep your microphone in mute. Okay, algorithms broadly into non-recursive or iterative, non-recursive, and the other one is recursive. Okay, these are also called iterative. Well, okay, analysis is same. Okay, no, analysis is same. This is the general plan that we follow. First, we need to decide on parameter indicating input size. Okay, input size. What next? We need to identify what is most important operation in our algorithm. That we call it as basic operation. Basic operation. Next, this step I'll come to this later. Okay, no, later. That is when I show the algorithm. That time we'll come back to it. This is most important step in algorithm analysis. Check whether the number of times basic operation is executed. It depends only on input size. Okay, that will come to it when we see an example. Next, let T of n be the time. Then you get an expression for T of n. Then simplify that. Simplify that. Okay. Then find its order of growth of T of n. Find order of growth of T of n. Then what is T of n here? This is basic operation count only. No, this is same as T of n. Then what is next? Next, represent basic operation count, operation count using either big O or big omega or theta or little o or little omega, some asymptotic notation. Let us see with this simplest example. So you need not worry about what is this algorithm and all. Anyhow, you can easily tell me, no, what is this algorithm? What does this algorithm do?
Sum of array elements.
That is, we are given an array of n elements. As I mentioned, I take indices from 1 to n, array indices. Okay, no? 1, 2, 3, 4, 5. This is name of the array is A. Okay, initially sum equal to 0. Okay, for I equal to 1 to n, it finds this and returns sum. Now you tell me what is input size here. For example, values are 10, 5, 20, 12, 14. What is input size here?
Array
What
size.
is input size here?
5.
5. That means number of elements given. Similar to sorting problem here also. Okay, n elements are given. So what is this? It is specific instance. It is an instance, specific values. It is an instance. Okay. In general, what is input size? What is input size? Parameter indicating input size. Input size parameter. What is input size parameter? Shall we take it as n? Yeah. No. In general,
N.
n. How many elements are given here? No, n elements are given. No. Next, in this algorithm, what is most important operation? What is most important operation?
Summing element.
Addition.
Addition.
For loop.
Okay.
For
No, which step? What is the most important operation in this algorithm? What is the most important step in this algorithm? Whether s equal to 0 or for I equal to 1 to n, s equal to
For
s plus
loop.
a. Of,
Sum and for loop.
which step? Second step or third step or first step?
Second step.
Second step is most
Second
important step.
For
Second step, what is that
For
we are
I.
doing? Are we doing actually anything? Any important
Iterating.
thing related to our actual problem?
No.
Iterate.
Third step, we're doing the addition.
Number of times the loop will be repeated.
third step is important.
Yeah, this is fine. This is fine. 1 to n we are doing. Okay, no, one variable we are taking and starting with, okay, it is same as for I equal to 1, I less than or equal to n, I plus plus, no? This is same, okay, in terms of that, okay, right? Okay. So here, what are the operations? Here, some comparison operation is performed. Some, what is that? Increment operation is performed. That means addition operation is performed. Okay. So out of all this, here also some addition operation is performed. Addition operation is performed. Out of this, what is most important operation? What is that? Out of this, what is most important? Because that should actually do the work related to our problem. No, that is finding array element sum.
Third step only.
This is the actual work we are doing. No.
Third
Here
step,
we are
sir.
adding one element with other element.
Hmm.
Okay, so that means what is basic operation we can consider here?
S equal
Sum.
to S plus A of I.
What is basic operation that we can consider?
Sum equal to 0.
No. No. What is the basic operation? Name of the operation. That's all.
Addition.
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 Addition. Next. I said no. Third step is most important step. What does this third step is say is let T of n is total number of
Elements in the array.
T of n be the no. Total number of
Basic operation is executed.
operations performed in our algorithm. Operation means basic operations. Operations performed when n is
Depends on the input only.
no.
It depends on the size of the input.
When n is input size. What does this T of n denote? T of n be the total number of basic operations performed in our algorithm. Basic operations performed in our algorithm. What is basic operation here? I can simply this basic operation I can replace with addition.
Addition.
Number both are same. Okay.
No,
Addition operation only, no? Number of additions performed in our algorithm performed when n is input size. When n is input size. Here, now you should tell if n equal to 1, what is T of n?
1.
When n equal to 2, what is T of n? When n equal to 2, how many
One
times
time.
addition operation is performed?
1 time.
This array contains only one element, 5.
Yes.
Array contains 2 elements, 10 and 5. How many times this addition operation is performed?
2 times.
2
2
times.
times. When n equal to 3,
3 times.
n equal to 3, how many times? Now, in general, it is very much clear that if you are told what is the value of n, automatically we can tell how many times this operation is performed. No, that means number
Yes.
of times
N times.
basic operation is performed.
N times.
Okay, no, T of n clearly depends.
N times.
Number of times.
On n only. On n only.
Yes.
Yes.
Now that means instead of 10 and 5, if our elements are 6 and 4, is there any change in T of n value? Number
No,
of times
no,
operation
no
performed?
change.
No.
Here also
No,
n equal
no.
to 2, no? Input size is 2 here, but
Yes.
instance both are same or not?
Instances are different, but n is execute only the same time.
Different instances, but same input size.
That
But
makes no
same-
difference.
Same input size. That means same input size, different instances. There is no change in T of n value. Is that correct? Is that correct?
Yes.
That
Yes.
means T of n clearly it depends only on n. T of n depends only on n. It does T of n doesn't depend on
The values.
depend on the instance. If different instance is also given, if n is same, it depends only on n. No. Here see,
Yes.
it does not depend on the instance. It depends only on n value.
And value.
Different instances, n is same means it is same. It is same. Is that okay?
Okay, sir.
Now you tell me how many times the T of n is performed. When I equal to 1, whether it is performed or not. I equal to 1, one time it is performed or not. 1 addition.
Yes.
I equal to 2, again 1 addition. I equal to 3, 1 more addition. And this one, I equal to n also 1 addition. Is that okay? This is number of additions.
Yes.
Number of additions. This entire thing in simple way, I can write it as sigma I equal to 1 to n irrespective of for each value of I, one time it is performed.
Yes.
This what is
Yes.
value of this? What is value of this? Sigma I equal to 1 to n 1. What is that value?
N.
Sir, n.
It is instead of that, if I ask what is sigma I equal to 3 to 8 1, what is this value?
3 to 8, sir.
Instead of 1, I put it from 3 to 8. I equal to 3, one time it is repeated. I equal to 4, one time it is repeated.
Only one time only.
6.
Then how many times it is repeated total?
6. 6 times.
This I can write it as 8 minus 3 plus 1.
6.
Yes, yes. Yes, sir.
In general, sigma I equal to some lower value to high value 1 means this is same as high minus low plus 1. But now if you are counting from 3 to 8, how many values we have counted? 3 to 8 you are counting. 3,
Yes.
4, 5, 6, 7, 8. Total 6 values we have counted, no?
Yes.
What is that 6? 8 minus 3 plus 1. In general,
Yes.
high equal to low to high 1 means it is high minus low plus 1. This will be using repeatedly. Please try to understand this. It is simple only. Okay. So what is this value? This n minus high is n, low is 1, low is 1, high
Plus
is
1.
n, low is 1, plus 1, yes. So it is nothing but n. Now tell me what is order of next 5th step? What is order of growth of T of n?
Big O of n.
No. What is order of growth of T of n?
Order of growth of
T of n. T of n is n. What is its order of growth?
N.
What is
N.
its order of growth?
N only, no?
N.
n.
Now,
1, sir.
no, n only, no. What is order of growth of n?
N.
Yes, sir.
N only.
N
sir.
only. It is. Now, next question is we need to represent it. Okay, we need to represent it using some asymptotic notation. Now, okay, let me write here. T of n, 6th step, I am writing here. T of n, can we write it as big O of n? Is this correct or not?
Yes, it's correct. So we can write.
Correct.
T of n, can you write it as big O of n square?
Yeah, we can also write that.
T of n, can you write it as big O of n power 100?
Yes, we can write that.
T of n, can you write it as big O of 2 power n?
Yes, we can write.
Others, are you following? T of n is big O of n factorial. Can you write this?
Yes.
Yes, sir.
T of n is big O of n power n.
Yes.
Among these, all are correct. But which is your favorite?
Big O of n.
This algorithm, if you find it in any textbook, nobody would have written it like this. Nobody would have written like this also, except only I only have written like this. Okay.
Order
No
of n.
textbook, no textbook you find big O of n square or big O of 1 power 100 for this algorithm.
Yes, yes.
But if they write like that, is it wrong?
No, asymptotically it is right.
No. Is it right or wrong? Only one.
Right,
one
it's
answer.
right.
It's right. But they don't write. Why? What type of bound big O gives? Now you please tell me. We have already completed, no? Big O. Big O, you tell
Yes.
me what type of bound it gives. That means
Upper
T
bound.
of n is big O
Upper
of n
bound.
means order of growth of T of n is less than or equal to order of growth of n. That is the meaning, no? T of n is big O of n means order of growth of T of n is less than or equal to order of growth of n. Are you getting?
Yes, sir. Yes.
Similarly, order of growth of n square. T of n is big O of n square means what does it mean? Order of growth of T of n is less than or equal to order of growth of n square. Out of these two, which is our favorite? We are looking for because we want actually what is order of growth of T of n. That's what people are expecting from us, no? So our
Yes.
answer should be close to actual order of growth, no?
Yes.
It
Yes,
is
sir.
like that yesterday or this day before yesterday's class, no? What is cost of this Corman textbook? One person said it is not more than 1 crore. 1 crore or less than 1 crore. Are you getting? One person said it is 1 lakh or more than, less than 1 lakh. Another person said it is 10,000 or less than 10,000. Another person said it is 16,000 or less than 16,000. All are correct. Among these, which is our favorite?
Order of n.
No, 1600 or less than 1600 is correct. Favorite answer, no?
Yes.
If you have
Yes,
1600 rupees, we can go on by Introduction to Algorithms by Thomas H. Corman. Okay, that means it gives more accurate information about the actual cost of the book. No, similarly, here writing like this, it is not wrong. But why should we simply give unnecessarily this type of bounds if we know that it is order of n? That means its order of growth is n. No point in simply giving this type of answers, no?
Yes.
Why in textbooks they write only big O of n.
Yes, sir.
So that reason behind that, is it clear?
Yes, yes.
So if
Yes.
we write big O
Yes,
of n
sir.
square, is it wrong? It is not at all wrong. But it is what type of bound you tell me big O notation gives? Upper bound or lower bound on the running time?
Upper bound.
Upper bound. Whether
Upper
that
bound.
upper bound is tight, whether upper bound is tight,
No, it is not tight.
it need not be tight. If you write big O of n square, is it saying that it is exactly equal to n square? No, it can be even smaller than n square also, no? So big O notation, what type of bound it gives?
Upper bound.
Upper bound. Whether this upper bound is tight, need
No.
not be.
No.
May or may not be. May or may not be. Need not be. It need not be. Okay. Okay. Now T of n, let us. Can we represent it using something like this? A T of n is big omega of 1. Is this correct or not? T of
Yeah,
n
it is
is
correct.
big omega of 1. Is that correct or not?
Yeah, it's correct.
It's
Correct.
correct. T of n is big omega of n power 0.1. Is this correct or not?
Yes, it is correct.
It is also correct.
T of n is big omega of log n. Is this correct or not?
Yeah, it is also correct.
T of n is big omega of n. Is this correct or not?
Yes.
Yes. Among this, which is your favorite?
Omega of n.
All are correct. Out of this, which is our favorite?
Big omega. Then.
What type of bound big
Omega of
gives?
n.
What type of bound big omega gives?
Lower bounds.
Lower bound.
Lower bound. Always lower bound should be, for example, when you ask for cost of introduction to algorithms by Thomas H. Gorman, one person said it is 1 rupee or more than 1 rupee. Another person said 10 rupees or more than 10 rupees. One person said 100 rupees or more than 100. Another person 1000 or more than 1000. Another person 1500 or more than 1500. All answers are correct. Out of this, which is our best answer?
1500.
That means it says it gives more information about the actual cost of the book, no? From this, that is clear that, okay, we should have 1500 rupees in our pocket or in our account so that we can buy the textbook.
Yes.
Okay, that is the meaning. That's the meaning. Now, similarly, here, T of n is big omega of 1, it is correct only. Big omega of n power 0.1 also correct. Big omega of log n is also correct. But among this, which is our favorite?
Big omega.
Big omega of n. This is our, why? Because this gives more accurate information about the actual order of growth of T of n, running time of that algorithm. Okay, that is our favorite. Here it is our favorite. Okay, now tell me what type of bound big omega gives?
Upper bounds.
No, big
Big omega lower bounds.
Lower bound.
Lower bounds.
It is lower bound.
Yes, big omega lower bounds.
Lower bound should be always as high as possible, no? Then it becomes our favorite, no? After writing an examination, if somebody asks how many marks you get, if you say that greater than or equal 0, that is better answer, or greater than or equal 40, that is better answer.
Yes.
You
Greater
one
than or
student
equal
being
to
a faculty,
40.
you ask one of the students after taking your examination, how many marks you get? Madam or sir, I'll get 0 or more than 0. Then we'll think, why did I ask that student? I wouldn't have asked, I shouldn't have asked, something like that. Okay. Now that means what type of bound it gives?
Lower bound.
Lower bound. Whether it will be tight always? Need not be. Why? Because if I write it T of n is big omega of 1, then it's not tight, no?
Yes.
Okay. So always lower bound should be as high as possible. Marks, no. I'll get at least 40, at least 60. Those are better answers, no? 60.
Yes.
In this examination, I will get at least 60. That answer is very good answer. Instead of saying I'll get greater than or equal to 1 mark. Okay.
Yes.
Always upper bound should be as small as possible.
As small as possible.
Lower bound should be
as high as possible.
As high as possible.
As high as possible.
Okay, last 1 minute, I stop. Now, T of n, can we write it as theta of n?
T of n, yes.
Yes, sir.
Yes.
Is that correct? Is that
Yes,
correct?
we can write. Yes, yes.
Is there any other way of writing using theta?
No.
Is this correct? Theta of 4 power log n base 4.
This is correct.
It's only overaction, but correct only. Okay.
Ultimately, it's n.
Yeah, it is n only. Okay, no, not different value. Okay.
Yes, sir.
Now, T of n, can we write it as little o of n square?
Yes, sir, we can write.
This is little o. Is that correct? Yes.
Yes, sir, it is
T of
correct.
n, can we write it as little o of n power 1.5?
Yes, that is also correct.
Yes, sir.
Can we write it as little o of n?
No, sir, that we can't
No,
write.
sir.
Not correct. Can we write it as little o of n power 1.5? 0.0001.
Yes, sir.
This is also correct. Out of this, which is our favorite?
N power 1.001.
What type of bound little O gives? What type of bound little O gives?
Upper bound.
Upper bound. Whether is it tight or not?
No, it is not tight, sir.
It is loose. It is not.
Yes, sir.
Not even one time it is tight. It doesn't actually say what is the cost of the book. It is something like that. Okay. What about theta? What type of bound it gives?
It's tight bound.
Exact. That means it is tight bound.
Yes.
That means it is tight bound. Okay. Similarly, T of n, can we write it as big omega, a little omega of 1?
Yes, we can write, sir.
Can we write it as little omega of log n?
Yes, we can write.
Little omega of root n?
Yes, we can write.
Little omega of n power 0.99?
Yes, it is right.
Among all these things, which is our favorite answer? Using omega, little omega, which is favorite? N power 1 is favorite, big omega, little omega of 1 is favorite, omega of log n is favorite, root n is favorite, or n power 0.99 is favorite?
Omega of 1.
No, simply.
Big O is
0.99.
What is the order of growth of T of n?
N power 0.99.
It says that it can be n power 0 or more. It says that log n or more. Sorry. It says that it is greater than n power 0. It says that it is greater than log n. It says that it is strictly greater than root n. It says that it is strictly greater than n power 0.99. All are correct. Out of that, which is our favorite answer?
A little omega of n power
That's a simple textbook example. No, that should clear all these things. The cost of the book, you asked one person said it cost is 1 rupee, more than 1 rupee. One more student said it is more than 10 rupees. One more student said more than 100. One more student said more than 1,000. One more student said more than 1,500. All are correct answers. Which gives more information about the actual cost of the book?
More than
which is closer to the actual price.
You want to buy a textbook. One student you asked, he said is more than 1 rupee. 1 rupee. Another student said more than 10 rupees. Another student said more than 100 rupees. Another student said more than 500 rupees. All are correct answers. Out of this, which is your favorite answer?
more than 500.
Why? Because that means at least we know that we should have more than 500 with us to buy the textbook. No. Similarly, here also same thing. T of n is little omega of n power 0.99 is our favorite answer. Okay. Is that okay?
Yes.
Okay. Now, running time of algorithm, T of n is some textbook they may write T of n is big O of n, same algorithm. Some textbooks they may write T of n is big omega of n. Some places they may write T of n is theta of n. Okay. If we, among all these things, which is our favorite answer? Best answer?
Theta of n, sir.
Big O of n.
Theta of n is best answer. Correct, no? If I ask what is the cost of the book, if one person says that it is exactly 1,500 rupees wherever you go and buy, then over. No more arguments. No. Okay. Okay.
Yes, sir.
So